All right, so this is the final review session of the quarter, review session for the final exam, and this one's going to be longer than the other ones, just due to the fact that it's a 3-hour exam. But the exam is designed to be done in an hour and a half, and you have 3 hours, so it shouldn't be that much of a time crunch. But just generally, it covers all chapters with a particular focus, I believe, on the later weeks. And yeah, so we'll start first with the Great Oxidation Event. So understanding what the Great Oxidation Event was, when it happened, what actually, was the result of this event, and, how it came to be and what's impact on the world. We then have the glacial period. So understanding, how Earth went through these 4 glacial / interglacial periods before the current era, and what causes. This is typically done by, Earth's orbit, the molecular cycles, so eccentricity, differences in, wobble and stuff like that around the sun and its elliptical orbit. So understanding that, and then going to the impact of global warming on the stratosphere. So understanding this, I believe, was in the homework as well. So how the increase in greenhouse gas emissions warms the troposphere, but actually cools the stratosphere by restricting the amount of radiative heat that can actually make it to the stratosphere. So just understanding the impact global warming has specifically on the stratosphere. And then this is somewhat more of a niche one, but look at the impact of volcanic eruptions on the stratosphere. So how volcanic eruptions emit aerosol particles, and then those particles can transform chlorine reservoirs in the stratosphere into active forms of chlorine that then actually destroy and catalyze ozone locally. And then we'll get into the difference between CO2 and black carbon. So just understanding generally the difference between CO2, black carbon, how they interact with different wavelengths, their actual properties when it comes down to heating. And then also just in general, understanding the impact of aerosols on surface temperature. So go back, look at the aerosols and their impact and how they interact with actual surface temperature, both maybe increase it and potentially decrease it. And then we had talked about the ozone hole. This was similar to the last review session, but the actual ozone hole appears over the Antarctic or the Antarctica, and you have these winters where you have these clouds, and then due to the cold temperatures, chlorine, different chlorine compounds bond to those or accumulate on those clouds, and then with UV they actually break down and then they destroy ozone later in spring. And then when spring happens, then the actual clouds disperse and then the ozone gets replenished back up. And it's a kind of a cycle. And then understand the difference between why the Arctic ozone dent is actually smaller than the Antarctic ozone hole. And then generally, ozone destruction by chlorine, you should know the actual, reactions, how this actually comes about, and then make sure you know the chlorine reservoirs. So the specific compounds, hydrogen chloride, chlorine nitrate, those are the big ones that you should know within the atmosphere. And then we have neutralizing agents. So looking at neutralizing agents, this was also touched on in the last review session, I believe. But understand, the differences: sodium, calcium hydroxide, calcium carbonate, sodium chloride, ammonia, magnesium carbonate. So understanding that and how neutralizing agents actually interact within the Earth sphere and their actual, impacts on acidic environments. And this is the last slide, and I'll hand it off to Paula. But also understand the acidity. So why is rainwater, have a pH of approximately 5.6, which is, acidic, and what does that impact on the Earth? And that's, death of forests, acidification of lakes, and various forms of erosion. And Paula, you can take.
Yeah. So for the second part, understanding the colors, the different colors that we have in the air. So for instance, the black colors in smog, and why, what are they due to, and why organic carbon appears brown or gray when it's burned. So just basically understand the basics of the different color in the sky. Yeah. And then for the Clean Air Act amendments of 1970, just do pretty much the same as, just know the basics, the basic characteristics of it, pretty much the same as in the quiz we had, the last quiz, I think. So just know the key features and like the key characteristics. And then ozone production from formaldehyde. We just want you to know kind of like I have like a broad overview of it, like what is involved, how is like the fact that like, ozone can be produced from formaldehyde, and what is involved, and like that's pretty much it. And then on the effects on ozone, so this is like a graph that we already had like in one of the review sessions, I think. And so just basically understand like how like NOx, for instance, like increasing NOx is going to have an impact on like urban air quality and on ozone. So just understand like what does this graph means, what does like the red lines means, what does it mean like if we're like on the top left or like the bottom right, and how is going to how like increasing NOx when we're like on the bottom right is going to affect ozone basically, and like the other way around. Then maybe some like historic part of air pollution. Why do we have air pollution? What are like the main causes and the main inventions that led to air pollution? For instance, gasoline, or like in the 20th century, and CFCs that led to ozone degradation. And then not finally, but next is the like how like ozone varies with altitude. So we just want to like you to not remember this graph, but we just remember that like at like a given altitude you have more like O3, and just like remember like the main characteristic of like each part of this graph, and how you can form ozone, and how you can like remove ozone too. So the main reactions that like are going to have either ozone as a reactant or a product. Then about visual range, I feel like all those concepts are like pretty broad, and we have like reviewed them in like several like in homeworks and review sessions. So we just want you to make sure that you like kind of remember them. Like for visual range, so what is visual range, and like look at prevailing visibility and see like along 50% of more of the horizon circle, like how much can you see? So you just add like the like visibilities, like ranges, like up to 50%, that's going to give you your prevailing visibility. And then the mixing ratio for ozone, the photostationary state mixing ratio, and what it depends on, like, and the formula, how it's like can be calculated. And then another formula would be the transmission of incident light. And how you can calculate T, and how you can calculate I, depending on like how it's going to be computed, and how it depends on X, which is like the most important thing. That's pretty much it. If you have any questions, I feel like most of the concepts we have shown here are like concepts we have used or like a lot. And so if you just like look at your homeworks and look at your like quizzes and the review sessions before, you should be fine. We're like, I don't think Mark is not going to ask you about like very specific stuff from like one page in the textbook. It's not,
and the reviews, I think the best studying thing is the review sessions that we've already done. A lot of it's in there. And a lot of the stuff that's like really specific, I think, or if there's not that much, there's not really anything that's that specific, but we covered a lot of stuff that you guys would need. So overall, I think just make sure you go through this review sessions and then homework, and you guys all should be good. Is the PowerPoint organized by chapter, or does it jump around? This jumps around. It is not organized by chapter, because the exam is not organized by chapter. So we kind of just went with the, generally how, data would get thrown in. So it's kind of random. But all the equations you have the equation number, which you can relatively easily find in the book. Math equations. You will not have to calculate really anything. There will be some formulas that you might have to manipulate, but nothing crazy. Like you're not like plugging in numbers. It's not like the homework where like you're calculating like kilograms of like CO2 per, vehicle mile. Like none, you're not plugging in any numbers. That's why you don't need a calculator. So it's more gonna be concept based, and then you might have to manipulate like some variables around. But beyond that, it's mostly all concept based and understand like the reaction that's happening. Would be an equation sheet. There will not be. Yeah, you want to go, Paula?
Oh yeah, sure. Well, you won't have any equation sheets. Yeah. So the like two we gave you would be better if you like remember them. But you also don't need to know any constant, like any value of any constant. Yeah, as like Alex said, we like won't have any mathsy things, so you should be fine. You just need to basically we just want to know, for instance, like in the last equation, like how it's going to like how like varying like increasing x is going to affect y. Yeah. So yeah.
Yeah, all these questions that have to do some sort of math are kind of like that.
Mm-hmm. For the chemical formulas, I feel like as long as you know, yeah. I mean, I feel like you should know by now, like the basic ones, like the ones you use like all the time. Just try to remember like what the reactants are. What the reactants are.
Yeah, I think you should know the reactions that are with ozone, particularly. Ozone's like a very important topic in this class. And I think we listed out, I think almost all the ones you probably would need to know. But understanding ozone reactions and what creates and then destroys ozone is relatively important, I think, for this exam.
Mm-hmm.
So I would say you should, like, if you're gonna spend time memorizing, that's the stuff you should like really look at. But at the end of the day, they all kind of react similarly with ozone. It's just different compounds. So if you get one figured out, you just plug it in and then just go from there. It's the same like catalyzation method typically. So yeah.
Jasmine, you have a question?
Yeah, so I was kind of curious. There's a question on the second quiz related to ROG and NOx, and one of them was referring to city A and city B hypothetically and giving certain scenarios. Is that more what would be on the test? Because there was one question related to Atlanta and ROG and NOx, and I don't remember talking about Atlanta in class or if there's anything important to know about Atlanta, but apparently for that quiz.
I don't think so. I would say the example I could give you is like, oh, we're like at very high concentration of like ROG. So we're like at the very top bottom right of the graph. How would like increasing NOx affect your ozone? Yeah. So
I don't think it'd be specific to Atlanta.
Okay.
Yeah.
I don't believe, are there office? I don't believe there's office hours.
I don't think so, no.
It's also because I also have finals, I think, during my office hours. So yeah, that would be tough. But you're always happy to get emails from you leading up to it. So if there's anything really big that you want to talk about, feel free. And then also like you can chat real briefly after class too, tomorrow.
I don't know about the quiz results. I'm not sure, like, we need to ask Mark, I think.
Yeah, we have to ask Mark about that, because, yeah, he sometimes uses them, so, again. But we can definitely ask and see. Any more questions? Can we, or could we email?
Oh, if you
our
have like a
one?
question about a specific like question in the
Yeah.
quiz, yeah, you can email us and we like
Yeah,
tell you more about it if that's the question you had.
all right. Any
I'm
more
going to
questions?
stop the recording.
Okay, yeah.